Okay, next, I want to share a concept with everyone called reward shaping. What is reward shaping? What we have learned so far is we take our actors to interact with the environment, getting a bunch of rewards. After some processing of these rewards, we get the score A here. With the score A here, you can teach your actor what to do and what not to do. But in this reinforcement learning, we are very afraid of encountering a situation in which the reward is always 0. Assuming that reward is 0 most of the time, only with a very low probability, you will get a huge reward. Then, what should we do? Assuming that reward is almost always 0. What does that mean? It means that no matter how you calculate this A, it is all 0. Which is the same for every action. No matter what action is executed, the rewards are all 0. So there is no difference between executing this action or executing that action. It is all the same. If the reward is almost always 0, no matter what action is executed, you have no way to train your actor. Talking about this kind of sparse reward problem, someone may immediately think of playing Go, which may be a sparse reward problem. Because when playing Go, every time you place stone on the board, you didn't get the reward. You did not get positive or negative rewards. Only at the end of the game, after finishing the last move, and the game is ended, will you get a positive reward when you win? Or will you get a negative reward when you lose? Compared to other tasks, the game Go is an RL task with rewards. For example, suppose today's task is teaching the robotic arm to fasten the screws. In the task that teaches the robotic arm to fasten the screws, your reasonable definition of reward is that suppose today the robotic arm successfully bolted the screw. It gets a positive reward. If it doesn't, the reward is 0. In the beginning, in your robotic arm, the parameters of the actor are random, so it just waved casually in the air. No matter how it waves, the reward is always 0. It's not like playing Go. At least you can have a positive or negative reward when you finish the game. In the robotic arm case, you ask the robotic arm to fasten the screws. Unless it happens to pick up a screw by coincidence, bolt it, and it gets a positive reward. Otherwise, no matter what it does, the rewards are 0. What should we have to do when we encounter this situation? One solution is that we try to provide some additional rewards to help our agent to learn. In other words, in addition to the original reward, which is the reward we want our agent to maximize, we also define some additional rewards. We define these additional rewards to help our agent learn. This method, that we define additional rewards to help the agent learn, is called reward shaping. You know that people are very good at reward shaping. For example, this technique reminds me of a story in the Lotus Sutra. This story comes from a chapter of Lotus Sutra. A leader is leading a group of people to find the treasure. The treasure is 500 yushin away. I forget how long yushin is. You just treat it as a very long distance. Just view this like 5 million kilometers away. This group of people walked halfway. They felt tired and didn't want to go any further. Everyone just sat on the ground and wailed. The leader saw that everyone didn't want to go any further, so he told everyone that there is a 5-star hotel 10 kilometers ahead. Everyone can go to rest. When everyone saw the 5-star hotel, they were happy and went to rest. The hotel disappeared the next morning. The team leader said that the hotel was made by his magic. The leader has magical power. The hotel made by magic was to encourage everyone to keep going, lest everyone gave up halfway. The story in Lotus Sutra tells what the Buddha hopes for everyone to achieve or Buddhism. The Buddhist path is very long. There are little saints, middle saints, big saints, and other different ranks to guide everyone forward. There is a more lifelike example. Take studying PhD as an example. You may think you can get rewards only after you get a PhD. Then you will feel, wow, this road is very long. I don't want to study PhD anymore. However, if I tell you that you can get rewards by taking a class first, then work on a small project, although there might not be any great result, the teacher will still say that you are great and you will get the reward. Keep moving on. Publish at a second-tier conference. Get some reward. Publish at a top-tier conference. Get reward again. Then eventually, you can graduate with a PhD. By moving forward step by step like this, you can eventually achieve the final goal. Here, I still encourage you to study for a PhD. You might be tired of hearing it again. But it doesn't matter. Since this course is almost over, there's no much time I can talk about studying PhD again. Okay, so this is the concept of reward shaping. What's next? Here, I am going to give an example of using reward shaping in RL. The example given here is called Viz Doom. Since I'm afraid that you don't know what Viz Doom is, let me show you a video. The Viz Doom is actually a first-person shooting game. People often use RL to play Viz Doom. The following is a video of playing Viz Doom with RL. That is to say, using a machine to play Viz Doom. Let's take a look at the video of the game. It looks like this. Every player here is not a human. Every player is a machine. So, if you look closely, you will find that some players have strange behaviors. For example, the player in the upper right corner is prone to get stuck. This person in the upper right corner is quite easy to get stuck. It's hitting the wall. Why is it? Because it's not a person. It's a machine. Okay, this is to let you know that what kind of game Viz Doom is. This video is very long. It's a 2-hour epic battle. If you are interested, you could watch it in your time. In the past year, the first place team of the Viz Doom game used the concept of reward shaping. In the game of Viz Doom, if you are killed by the enemy, your points will decrease. In contrast, your points increase if you kill the enemy. But, if you just rely on the real reward in this game to train the agent, it's hard for you to train it. So, in this article, they use some concepts about reward shaping. We could take a look at how they define these rewards. We will skip the first point and go back to it later. We first look at the second point. The second point says that if the blood decreases, you get a negative reward. In fact, there is no penalty for blood decreasing in the game. Blood decreasing does not reduce points. Only when you die, your points decrease. But, if the machine gets a negative reward, only when it has died. It may take a long time to learn the relation between blood decreasing and death. So, we tell the machine directly that it should not make blood decrease. Blood decreasing is a bad event. Next, some points are deducted if you lose ammunition. Add points if you find a medical kit. Add points if you find ammunition supply. These things will not affect the score in the game. But we humans, we developers, impose these on the machine to guide the machine's learning. Then there are some more interesting rewards. For example, if your agent always stays at the same place, points will be deducted. Why do we need such a reward? Because if you don't have such a reward, and the agent is really weak at first, it may go out and walk just 2 steps and get killed by the enemy. So, for the agent that was weak at the beginning, the strategy to get a higher reward is to stay at the same place. At least this way, the reward is 0. If it goes out and runs into an enemy and has its health deducted, that's not worth it. So, in order to avoid the machine not learning anything, and stay right where it is, we forcefully tell it that points will be deducted if it stays at the same location. And we also tell it that if it moves, it will get a small score. Every time it moves, it gets 9 times 10 to the power of -5 points. A very small but positive reward. But it's not enough to ask the machine to move. So here is another very interesting reward. This reward is if the agent is alive. Every time the agent is alive, points will be deducted. You may think it's weird. Isn't being alive a good thing? Why should points be deducted if it's alive? That's because if there's no penalty for being alive, or if it's a positive thing for the agent, what it will learn may only make it an observer. Although you told it to move, it would ignore your instructions and just keep rotating in some corner. It would avoid the enemies or any conflict and just keep rotating in some corner on the map. For your agent, that was perhaps the safest way. But, in order to force the agent to learn how to kill the enemy, you would instead have to tell it that living would have penalties. It would have to find a way to not live for too long and fight against other players. So, this is a very interesting way of doing reward shaping. After seeing these ways of doing reward shaping, You would actually find that it requires some domain knowledge. It is actually enforced based on the researcher's understanding of the environment. Let's give another example of reward shaping. Suppose you want to train a robotic arm. The task of this robotic arm is to put this blue board onto this stick. For a task like this, it is not easy to use RL to teach the machine to put the blue board onto this stick. However, you might think of a very intuitive method of reward shaping. The closer the blue board is to the stick, the higher the reward. But if you think about it, you will find that it's not quite enough to just get the blue board closer to the stick. Why is that not enough for the task? You can take a look at these two cases on the right. The robotic arms are also performing the same task. But what it did was actually just bashing the stick. Approaching from the side is useless. You can't achieve your goal by approaching the stick from the side. So giving more rewards whenever the board is closer to the stick is too naive. Using reward shaping, you let the reward be a function of the distance. But it might not be helpful for solving the problem in some cases. That's why you should always be careful. While using reward shaping, it requires you to have a sufficient understanding of the problem. Okay, let's stop and see if any classmates have asked questions. Well, no classmates are asking questions. So let's continue. There is an interesting and well-known method called curiosity-based reward shaping. As its name implies, we give the machine curiosity. What does it mean to give curiosity to a machine? Curiosity means the motivation to explore new things. We are going to add a new term to the reward. If the machine discovers new things during the process, it receives additional points. But there is a caveat. New things must be meaningfully new. What does this mean? I'll explain this later. This method, the curiosity-based reinforcement learning, origins from an article published at ICML 2017. There is an amazing demo in this article. Let me show you. I want to explain the meaning of the video. Let me stop the video. Wait for me. It makes the machine play Mario. In the game Mario, there is no reward. He didn't even tell the machine that it can get a positive reward by passing the level. Actually, it's useless to tell the machine that it can get a positive reward if it passes the level. This kind of reward is too sparse. It is difficult to use this reward to train the agent. It only tells the machine that you have to keep seeing new things. That alone can make the machine learn to pass some levels in Mario. This approach may be the most suitable approach for Mario. Mario is a side-scrolling game. If you want to pass the level, you have to keep walking to the right. If the machine wants to see new things, it needs to keep going to the right. So, the machine can learn to pass some levels in Mario only by curiosity. It has been tried that the agent is trained in the previous levels and then directly test. In the underground level, it failed. At the underground level, we still need to fine-tune some networks. Okay, the video has the second half. We just start watching it from somewhere. Okay, next, He directly asks the machine to play Viz Doom. He directly asks the machine to play Viz Doom. Let's also play the part of Viz Doom. Okay, there is a lot of noise in the last background. It's kind of like the screen full of noise. When the TV is broken. You may not know what it wants to express in this video. This part is the meaningful new thing I mentioned earlier. Wait for a second. The meaningful new thing is that we assume we require the agent to always see new things. If there is a noise in the background of your screen, the noise will keep changing. So the noise is new to the agent. Maybe it won't learn to explore new environments, since just standing there and watching the noise is enough. It thinks that it keeps seeing new things. So actually, in curiosity-based RL, there are also ways to overcome this meaningless new thing, the problem of seeing noise. As for how to actually solve it, you can refer to his paper.